Cumulative frequency for discrete data. Welcome, everyone. Before we dive into today's new topic, let's take a moment to reflect on what we've already mastered. In our previous lesson, we learned how to find the median by simply arranging a basic list of numbers, or what we call ungrouped data, in order and picking the middle value. However, as you move into more advanced statistics, you'll notice that real-world data is rarely presented as just a simple list. Instead, it is often organized into what we call a frequency distribution table, where data is grouped by how often it occurs. Now, imagine you are dealing with a dataset of thousands of entries. Trying to write out every single individual observation one by one would be incredibly tedious, time-consuming, and quite frankly, inefficient. To handle this more effectively, we use a powerful mathematical tool called cumulative frequency. Over the next few slides, I will show you exactly how this concept works and how it makes finding the median much more manageable. Understanding cumulative frequency. Now that we've established why we can't simply list every single number when dealing with large datasets, let's dive into the core concept of this lesson: understanding cumulative frequency. Think of cumulative frequency as a running total. Just like when you keep a running score in a game, you aren't just looking at the points earned in the current round, but the total points accumulated from the very beginning up to this moment. To be more precise, we calculate this by taking the frequency of a specific observation and adding it to the sum of all the frequencies that came before it. It's a process of accumulation. If you're looking for a simpler way to wrap your head around it, try this. The cumulative frequency for any specific value tells us exactly how many observations in our entire dataset are less than or equal to that particular value. This is a crucial distinction because, as we will see in the next few slides, this less than or equal to logic is exactly what we'll use to pinpoint the median. How to construct a cumulative frequency table. Now that we understand what cumulative frequency represents, which is essentially that running total we discussed in the previous slide, let's walk through the practical steps of how you actually construct a cumulative frequency table. First, you need to list your observations. This is your variable, which we call x. It is crucial that you arrange these data values in ascending order, meaning from the smallest value to the largest. If they aren't in order, the running total concept won't work correctly. Second, next to each of those observations, you must list the frequencies. We denote frequency with the letter F. This tells us how many times each specific value appears in your data set. Finally, this is the most important part: calculating the cumulative frequency, which we represent as CF. To do this, we use a step-by-step addition process. For the very first observation in your list, the cumulative frequency is simply its own frequency. There is nothing to add to it yet. Moving to the second observation, you take the cumulative frequency you just found for the first value and add the frequency of this second value to it. For the third observation, you take that new total and add the frequency of the third value, and so on, continuing this pattern all the way down the table. By following this method, you are building a cumulative total that, as we will see in the upcoming slides, allows us to pinpoint the median much more efficiently than looking at a raw list of numbers. Finding the median using cumulative frequency. Now that we know how to build that running total, let's discuss how to actually use it. The beauty of having a cumulative frequency table is that once it is ready, you can identify the median immediately, without the tedious task of rearranging every single individual data point into a long list. To do this, we follow a simple, step-by-step process. First, you need to find the total frequency, which we represent with the letter N. To do this, simply sum up all the frequencies in your table. This number, N, represents the total number of observations in your entire data set. Second, we need to determine the median position. To find this, take your total frequency, N, and divide it by 2. This gives us the halfway point of our data. Third, we must locate the correct median value. This is where you look specifically at your cumulative frequency column, the CF column we just learned about. You are searching for the very first cumulative frequency value that is greater than or equal to n divided by 2. Finally, once you have found that specific cumulative frequency, look across to its corresponding observation, which is our x value. That specific x value is your median. In the next few slides, we are going to walk through a real-world example involving students and books to see this exact process in action. Real-world example. Now that we understand the theory behind cumulative frequency, let's put it into practice with a real-world example. Imagine a teacher has recorded the number of books read by 20 students during their summer break. Instead of looking at a long, messy list of individual numbers, the teacher has organized this information into a frequency table. Our goal for this exercise is to use the steps we just learned to find the median number of books read from this specific distribution. Looking at the table provided, our first column, labeled X, represents the number of books read, ranging from 0 to 4. The second column, labeled F, shows the frequency, or how many students fall into each category. For instance, 2 students read 0 books, 5 students read 1 book, and so on. Construct the cumulative frequency table. Now that we have our initial data from the previous slide, let's put the theory into practice by constructing our cumulative frequency table. Looking at the first row, for 0 books, the frequency is 2, so our cumulative frequency starts at 2. Moving to the second row, where the number of books is 1, we take that previous total of 2 and add the current frequency of 5, which gives us a new cumulative frequency of 7. For the third row, with 2 books, we add the frequency of 8 to our running total of 7, bringing us up to 15. Next, for 3 books, we add the frequency of 4 to our previous total of 15, resulting in a cumulative frequency of 19. Finally, for the last row, where the number of books is 4, we add the frequency of 1 to 19, which brings our final cumulative frequency to 20. Notice how this final value of 20 matches our total number of observations, which is exactly what we need to proceed to the next step of finding the median position. Calculate the total number of observations. Now that we have successfully constructed our cumulative frequency table in the previous slide, we move on to step 2. Before we can find the middle of our data, we need to know exactly how many data points we are dealing with in total. To do this, we calculate the total number of observations, which we represent with the letter n. If you look at the very last entry in our cumulative frequency column from the previous slide, you will see that the running total ends at 20. Therefore, our total number of observations, or n, equals 20. Find the median position. Now that we have identified our total number of observations, which we found in the previous step to be 20, we move on to step 3, finding the median position. To do this, we take our total number, n, and divide it by 2. So, 20 divided by 2 gives us 10. This means we are looking for the 10th observation in our data set. Keep this number, 10, in mind, because in the next slide, we will use it to scan our cumulative frequency column to pinpoint the exact median value. Identify the median. Now that we have determined our target position is 10, we move to the final step, identifying the median. To do this, we scan down our cumulative frequency column, looking for the very first value that is greater than or equal to 10. Let's check them one by one. First, we see a cumulative frequency of 2, which is clearly less than 10. Moving down, we find a cumulative frequency of 7, which is still less than 10. However, the next value we encounter is 15, and since 15 is greater than or equal to 10, we have found our target. Now, look closely at the table to see which observation this value belongs to. The cumulative frequency of 15 corresponds to the number of books being equal to 2. Therefore, our median number of books read is 2. Common mistakes to avoid. First, a very common mistake is confusing the frequency, which we call f, with the cumulative frequency, which we call CF. When you are looking for the median, your eyes might instinctively jump to the frequency column, the number of times a specific value occurs. However, As we saw in our example with the books, the frequency column alone won't tell you where the middle of the data set lies. You must always ensure you are looking at the cumulative frequency column to locate the correct position. Second, please be mindful of the order of your data. Cumulative frequency only works correctly if your observations, which we call X, are arranged in ascending order, from smallest to largest. If you are given a table where the values are scrambled, you must rearrange them into ascending order before you even begin calculating your running totals. Finally, watch out for calculation errors during summation. Remember, the cumulative frequency is a running total. This means if you make a single mistake while adding a frequency, every single value following that mistake will also be incorrect. This creates a domino effect that will lead you to the wrong median. A great way to prevent this is to double-check your work by ensuring that your very last cumulative frequency value is exactly equal to n, which is the total number of observations in your dataset. Now, before we wrap up today's lesson, I want to pause and discuss some common pitfalls. Even when you understand the concept, it is very easy to make small errors that can lead to the wrong answer. If you keep these 3 points in mind, you'll be well on your way to mastering this topic. Key takeaways. All right, we have reached the end of our lesson. Let's quickly recap the key takeaways to ensure you have a solid grasp of the topic before we wrap up. First, let's revisit the definition of cumulative frequency, or CF, as we write it. Remember, it isn't just a random number, it is the running total. Specifically, it is the sum of the frequency of a particular observation and the frequencies of all the observations that came before it in our ordered list. Next, why do we bother with this? What is the purpose? As we saw in our example with the books read by students, the purpose of using cumulative frequency is to help us pinpoint that middlemost observation within a frequency distribution without having to write out every single data point one by one. It streamlines the process of finding the center of your data. Finally, I want you to memorize this golden rule for finding the median. The median is the specific observation, or the value of X, whose cumulative frequency is the very first one to reach or exceed the value of n divided by 2. Just remember, find your total number of observations, divide by 2, and look for the first cumulative frequency that meets or surpasses that target. If you can master these 3 points, you are well on your way to mastering discrete data analysis. Great job today!